So this is the cheat sheet review for the last several lessons that we went over from about 59 to 64. I'm going to do things a little bit differently. Got some feedback that, hey, why are you typing things out? Why don't you just paste them in and talk about them instead of us watching you type things in? And I had no good reason why. Honestly, I had something in my mind when I started out, but in execution it wasn't quite as good as I thought. So here we go. We're going to paste stuff in. So let's paste in the title of the next item in the cheat sheet, creating a database in Visual Studio 2013. Now there's a lot of hands-on things that we did in that lesson where we actually added a database to our project and then we used the SQL Server data tools. What I'm going to add to the cheat sheet, however, is just basically talk about LocalDB, which is a local dev-only version of SQL Server that you use during development time. And then we'll see in the very last video how that can be scripted and sent out to like a production environment SQL Server, like we'll do in Azure SQL. And so basically, the only thing you really need to remember how to do here is to go to Project, Add New Item, Install Data, SQL Server Database, select that item, give it a name. It'll give you a .mdf file extension, and it'll give you a second file that's I think LDF. That's for the log file. So let's just put here creates an MDF file, which is your database. And then also we double clicked on it in the Solution Explorer and it opened up the structure of the database, like the tables and the other objects on the database in SQL Server Data Tools, and we said that this is installed by default in the Express versions. It's an option in the other tools like Ultimate and even Community, or it can be a separate download, or it can be added from the update, the little flag in the upper right hand corner. But it basically has tools that allow you to manage and create SQL Server databases from directly within Visual Studio without having to bail out to SQL Server Management Studio, which comes with SQL Server. And that's pretty much all that I want to add to the cheat sheet there. Feel free to add other items that you might feel are pertinent. The next thing we talked about then is creating an entity data model in Visual Studio 2013. So we're using the entity framework, and we added an entity data model similarly to how we added the database. And let me just paste that in. We went to Add New Item, Install Data, ADO.NET Entity Data Model. That opened up the Entity Data Model wizard, and we stepped through that with choosing most of the default selections, like the EF designer from the database. We chose the connection string. We chose which database objects, things of that nature. But what is the Entity Data Model? It's essentially just an object relational mapper that allows us to treat database tables, which are created with a relational database philosophy, treat them as if they're classes with properties, which is an object-oriented philosophy. And for the most part, in simple cases, those two will match up, but there will be cases where relational database management theory will lead you off into a different way, partitioning the data, separating the data off into separate tables, and object-oriented programming will go on from there. But in very simple cases, you will probably see a one-to-one correlation. At any rate, then we took a look at what we needed to do from a code perspective to actually use the entity data model that was created. First of all, we need to create an instance of a DB context, and some of these things like the DB context, the DB set, even the entities themselves are generated automatically using T4 templates in Visual Studio, and then we're just accessing them from our own code that we write. So we created an instance of a DB context, which is your handle onto the database. It says I need to connect and do something on that database. And then a DB set is a collection of entities that is accessible through that DB context. And so here's a quick example of the two of them kind of being used in two lines of code here, where I have an entity data model, a DB context rather, called Acme Entities, and then I'm going to get a list of all customers by just using the db.customers. The customers DB set should be automatically generated for us from a customer table in our SQL Server database, and so by calling db.customers, we're calling generated code to return us all rows from the data instantiated as instances of a customer object saved into a DB set, a collection of customers. Okay. Going on from there, then, I showed how we could use a server control called the GridView control in order to display DB sets into on our ASP.NET webpage. Instead of using some sort of for each statement and then kind of concatenating on all the HTML that we need, we could just use the server control and use a function called data binding, which we'll talk about in just a moment. But essentially, GridView server control data binds to innumerable collections of objects and renders them out in a tabular format. And so one thing that I said, there's a little bit of a disconnect between what you get in a DB set and what the GridView server control needs in its data source property. You have to basically call a toList on the DB set. So it will look sort of like this chunk of code right here. So grid control dot data source equals the DB customers dot toList. This will give us a list of customers because data source can't work with the DB set. And then we talked about data binding. Now, I don't have it listed here, but data binding is that that functionality built into a server control that allows it to, it gives it presentation logic to take a collection and know how to render each item in the collection into some format, into some templated format. In this case, it's in a grid view, but there's other different like list views and things of that nature. And we'll learn about more of those as we move on into the ASP.NET web form fundamentals. Which I'll record at some point in the future. Okay, so that pretty much finishes up Lesson 61. Lesson 62 then, we went a step further and we said not only can we just display data, but we can also make it kind of interactive. And there's a number of different ways to do this, but we just did a very simple use case where we chose the little arrow, the little chevron in the upper right hand corner of the grid view and selected edit columns from the GridView tasks menu, and this opened up a dialog that allowed us to basically manually configure the different columns or the fields that would be displayed in that table. And there were a couple of different kinds of columns. The two that we focused on were the bound fields, which just simply displayed a given property of an entity from our DB set. And then there was a button field that allowed us to create like a hyperlink that when you click on it, we can respond to in code. We'll talk about that in just a moment. In fact, let me just paste that in here, that we can handle the button click in a event called the row command event handler. And so I'm just going to paste in an abbreviated passage of code that you can use in the future in order to access the given row and cell that was the row that was selected when you click the little, in our case, the little view hyperlink in the leftmost column, and by clicking that, it's associated with that whole row in the table. And now how do we get to that row in the table and access all the data in the individual cells of that row of the table? Well, the row command event will give us something called the GridView command arguments, which is just simply in the moniker E, and so we can access E.command argument, and that'll give us the index of the of which row was selected, and then we can just kind of use our parenthesis operators to index into the collection of rows in that grid view. And now that we have that row, we can get to individual cells of that row by using, again, the square bracket operator to index into one of the cells in the cell collection to grab out the text. And then we can do anything we need to with the text. We can, if it's an ID, we can convert it to an integer or to a GUID in order to then look it up in the database or whatever the case. So moving on then, let's go, and we started talking now at a higher level between the difference between tool-centric and maintenance-centric or maintenance-driven application development. These are terms that I created, just so you know, because I felt like it explained the two different paths that you can go down when building applications. And there might be gradations between these two extremes, but essentially, when you're taking a tools-driven approach, you're really, and let me paste this in here, you're using Visual Studio's many designers and tools and windows and wizards to build applications writing minimal amounts of code, which as I said, is great in certain scenarios. Now, if you have a small application you need to build on a tight time frame, few people will be using it. It's a departmental level application. There's very little business logic involved in it. It's basically what I call a CRUD style application, where you're just creating records, reading records, updating records, and deleting records. And you don't anticipate a lot of change over the full life of that application. Then it's perfect in that scenario. But then I introduced its corollary on the maintenance side, and talking about the approach to developing maintenance-centric applications. And this is where you anticipate change and you want to mitigate the impacts of change on the application by separating concerns out, applying the practice of unit testing and other practices as well, which we talk about in several entire series later on in the curriculum on LearnVisualStudio.net. The other thing that I would say about it is that unlike the tool-driven approach to building applications and its limitations, but its benefits, you see the opposite on the maintenance-driven side. It's great for larger applications, enterprise-scale applications where you have a lot of business rules. It's not simply CRUD-style applications, where you anticipate a lot of change throughout the life of the application. And the application is crucial to the operation of the business, and as business rules change, the application has to change along with it. And typically there is the allowance for a much longer development time frame, whereas you can probably throw together a tools-driven application in a couple of days or maybe a couple of weeks. With a maintenance-centric application, you're talking about probably at a minimum a couple of weeks, more likely a couple of months or maybe over a year to get all the functionality that you need. And then we demonstrated how to build that type of application. And when we talked about separation of concerns, we talked about the three typical concerns or layers that you would add to an application, right? There was the presentation layer, the domain layer, and then the persistence layer. And then as we were building this application, I introduced another layer in essence. It is the data transfer object layer. It would be utilized by the other layers in the application. And so it's simply just a model, a series of POCO or plain old CLR objects that are used to transfer the data from one layer to the next. Why do you do that? To enforce the separation of concerns, to make sure that your concerns do not leak from one level, or the abstractions don't leak from one layer to another layer. So for example, if we are going to use the entity framework in the persistence layer, we don't want the entity framework to leak out of the persistence layer at all. So to the domain layer, it should never have any knowledge of what's going on inside of the persistence layer. It shouldn't know what technology is being used. We should be able to swap out that technology, and the domain and the presentation layer should be none the wiser about it. So and we use data transfer objects so that we're not transferring back a DB set of entities to the domain. We're rather sending back a generic list of data transfer objects that well represent the model of the application that we're building. Okay, hopefully that made sense. And I think that's pretty much all we're going to cover in this cheat sheet review session. Keep in mind that while I just pasted this in, you can always just copy and paste from the very first lesson. If you look at the directory of lessons for this given course, it's the one that has 000, the cheat sheet, and you can just copy all of the embedded cheat sheet code from the GitHub gist and paste it into your own text file. Okay, so we'll pick it up in the next lesson. We'll see you there. Thanks.